Let me interrupt and make sure that we're understanding this correctly. In class, remember our first meeting. You're using LEDs and they are emitting in the infrared.
Yes.
And they are mounted in some way on that band that goes around the head. And though then you control the emission of the LED, you can basically turn them on.
Exactly.
And then it penetrates the skin and the bone.
Yes.
And causes excitation in the brain. Is that correct?
Exactly. And we have a slide about that, how the light enters into the cortex. Because imagine, though our skull is bone, there are some wave lengths that can penetrate through the skull and go to your brain. So there's an amazing discovery that we are capitalizing on to look into the brain. We can look on the surface of the brain. You know, the brain is like a small sphere, you can imagine, and the surface is where we have all our important brain activities happening, the cortex. So we are able to see the blood oxygenation in the cortex, which means if the brain needs to function, if it's activated by paying attention or trying to form memory, it will bring red blood, oxygenated blood. And we will see that signal. And when activation utilizes this oxygen, the blood will become blue. We will see that too. This is what we call oxygenated blood, deoxygenated blood.
Okay, so you are measuring, or you are looking at the absorption of
and
scattering that is due to oxygen in the blood, in the brain.
Exactly.
Now, what is the receiver? How are you capturing this information? You are sending it using the LEDs. How are you
And we have a light detector, as I showed you. Let me show this again to the camera. As you can see, these are the sources, and these are the detectors.
Okay.
And they are surrounded, like they are like the source is in the middle, and there are 4 detectors around, and we measure underneath the detector. So we know exactly where we're measuring.
So what does the image look like?
Actually, do we have an image in this slide? We probably do not, because we put such few slides. I don't think we put the image. The image is like it's like a sort of a pulse signal. It's a very easy signal to sort of appreciate. It rises and falls, and you can also turn it into an image that sort of represents your forehead. But somehow we should have chosen those for you. If you move to slide 6, quickly move to slide 6. If you move to slide 6, okay, you see the headpiece here, and you see also on our screen now the signal that is happening. The red thing is telling us that a piece of, this is on our forehead, the part that is being oxygenated. Okay. Is that clear?
That's clear. Now, are we looking at the right one?
Number
the next one.
6. There is a headband on top. There's a woman wearing the...
Okay, I think we did have it. Okay, let me, how much time do we have? Somebody? 12. Okay, we've got plenty of time. Okay, Banu, tell us something about who else is doing this?
There are several groups working on this technology. We are basically in friendly competition with all of them. A very large group in Harvard, a very large group in University of California, Irvine, another one in London, another one in Germany. Now, one of our former students from our program has now started also an initiative back home in Istanbul, Turkey. But also, Dr. Chance, who is the brain behind this discovery, also educated many Chinese students, and in China we see also a lot of competition happening. However, I can say safely that our team, which is composed of not only biomedical engineers, electrical engineers, device engineers, IT people, so on and so forth, but neuroscientists, neurologists, and anesthesiologists, psychiatrists, is probably the one that is most advanced in the world in monitoring cognitive activity.
Amazing. Tell us, you've taught engineers of all flavors,
Yes.
IT people. With whom are you working on the clinical side? Are the physicians working with you?
Very many physicians. Let me just sort of get obviously a list for you. First of all, for the pediatric applications, we work with neonatologists because they are the ones that are who are most curious about the baby's brain. And for the adults, we work more with the obviously neurologists, especially those who deal with neurorehabilitation patients who have had traumatic brain injury. And we also work with clinical psychologists who work with such patients from behavioral rehabilitation. We have psychiatrists, several psychiatrists working with us because we have projects on addiction, on also autism, and also on we're beginning an activity also in attention deficit disorder children. And another big group that work with us is basically our people work with them in their environment are the anesthesiologists. One of our major projects is to monitor the depth of anesthesia so that patients under surgery do not wake up. So that's a very big one. By the way, I'd like to invite all the students and the faculty who are attending this session to go to our website, Biomed, of course, we're web, Biomed Drexel EDU, and you can enter into our life-saving solutions. And if you sort of visit these technologies, you will come to a point where we talk about this optical brain imaging technology, and you will see all the applications that you can imagine that we are deploying this technology for.
Well, let's just make that an assignment. Is that okay, Professor?
Oh, that's perfect. By the way, they should, while they're on our website, they should go into virtual Biomed. Also visit our facilities and our laboratories. We have very special laboratories, and they should know that you are the one who are the architect behind this building. So if they like it, it's because thanks to you.
Thank you, Banu.
So what I'd like to do is to go to the last slide before I take the questions and talk about how we commercialize the technology, how we work with the businessmen to make this come to the patient. I'd like to talk a little bit about the evolution of the technology.